Hi, for this video what we're going to do is we're going to solve a rational equation. For this particular rational equation, in order to find the LCD, we do have to factor all of our denominators to see what we have in common. So I'm going to start by factoring this right here. I'm going to leave the top alone. I'm not going to try to factor that because that's just work that wouldn't help us. So the top, like I said, is going to stay the same. The denominator, what we're going to do, remember that we're looking for two numbers that multiply together to give us negative 15, that add up to be negative 2. And so those two values, since this is negative, that tells me that one of these needs to be positive and the other one needs to be negative. So, and the larger of the two has to be negative since I want a negative in the middle. So negative 5 and positive 3. A negative 5 times positive 3 gives me the negative 15 that I need, and then the negative 5 plus 3 gives me the negative 2. By doing this, what we can see is that both of these have a p minus 5 in common. If they wouldn't have had those in common, then our LCD would have been all three of them. So our LCD is going to be p plus 3 times p minus 5, or because this one doesn't have a denominator, we could go ahead and multiply this back out and say that it's p squared minus 2p minus 15. So what we're going to do is we're going to multiply everything in here by the lowest common denominator. So I'm going to take the p plus 3, p minus 5, and I'm going to multiply it by what we already have, the p squared minus 3p plus 2 over the p plus 3 times p minus 5. And then we're going to take and multiply the 1 times, in this case I'm going to use the p squared minus 2p minus 15 just because it's easier to multiply. So I would have the p squared minus 2p minus 15. And we're going to multiply that by the 1 plus, and then because this one has a denominator, I'm going to go ahead and go back to the factored form. So p plus 3 times p minus 5. And we're going to multiply that by the 1 over p minus 5. So once you find the lowest common denominator, like I said, depending upon the situation, like for this one, because it doesn't have a denominator, it makes more sense to leave it as the trinomial. For the other two, because they have the factored form, it just makes it easier to see what you have in common. So the p plus 3's can cancel. The p minus 5 cancels. So on the left-hand side, we're left with the p squared minus 3p plus 2. And on this side, when I distribute the 1, it doesn't change anything. So we just have the p squared minus 2p minus 15. And then for the last one, what happens is the p minus 5 cancels out, and we would just do the 1 times p plus 3. Because I have a p squared on both sides, these do end up canceling each other out, so this does not end up being quadratic. We just have a linear equation that we have to solve once we get rid of the denominator. On the left-hand side, I'm going to go ahead and combine like terms, so the negative 2p and the positive p gives me negative p. The negative 15 plus 3 gives me the negative 12. And then because we have variables on both sides, remember that we want to move the smaller one. So I'm going to go, the smaller one. So I'm going to go to move the 3p. So I'm going to add 3p to both sides. That cancels out over here, so we're left with the 2p. And on the right-hand side, I'm going to go ahead and bring the 12 over at the same time. So I'm going to add this 12 to both sides. And so we end up with 2p equals 14. And so our final answer is p equals 7. Remember that we have to make sure that this is not an extraneous solution. Remember that it is undefined if the denominator is 0. So if I plug 7 back into the original equation, we want to make sure that this does not give us 0. And we can see that the denominator is the p plus 3, the p minus 5. So the two solutions that we would have got, p could not equal, the ones that are not in the domain, is negative 3. And p cannot equal positive 5. So since we didn't end up with either one of those as our solutions, This has a very good chance of being the correct solution. So what I'm going to do is I'm going to go ahead and check it by plugging it back in. And so if I plug it back in, I replace all the p's with 7. So I would have 7 squared minus 3 times 7 plus 2. And all I'm doing is plugging it back into the original equation, just replacing all the p's with 7. I know you can't see that, but I have it written down. So 2 times 7 minus 15 equals 1 plus 1 over 7 minus 5. So all I did was I replaced all the p's in the original equation with the 7. And then if we check to make sure that this does indeed work, we'll simplify this side first just because it's easier. So I really have 1 plus 1/2, or 3/2 if I write it as an improper fraction. Sometimes it's easier to work with the improper fraction rather than a mixed number. You can express it either way. We could also put this as a decimal as 1.5. You can plug this entire thing into your calculator if that's easier for you. For this one, we would end up with 49 minus 21 plus 2 over 49 minus 14 minus 15. And this ends up giving us 30 over 20, which does reduce to 3/2, so we do know that this is equal. As always, thanks for watching. If you have any questions or need clarification on anything, please just let me know in the comments. Also contact me if there is anything that you don't see, any topics that you don't see that you need help with. As always, thanks for watching.